So for part C, we're given that the function f is equal to secant x. And so what we want to do is find out what the second derivative of this particular function is evaluated at when x is equal to pi over 4. And so just to introduce this notation to you, if we wanted to write it in Leibniz notation, it would look that way, okay? Or this for short. And of course, we want this evaluated at 3. So those are alternative ways we could write that notation. All right, so we need to take the derivative of this function twice. So if we start off taking the first derivative of it, we know that the derivative of secant is secant x tan x. And so see that right here. Okay? And so that's the easy part. Now to take the second derivative, we notice that we have two functions here that are being multiplied by each other. So we need to employ the product rule to be able to do that. So here we take the derivative of the first times the second plus derivative of the second times the first. Of course, we look here, the derivative of secant, again, is secant x tan x. And all that multiplied by tan x. And of course, the derivative of tan x is going to be secant squared x. Okay, so from this point, we're pretty much on easy street. Go ahead and combine whatever like terms we can. Okay. And so here, what we actually could have done is factor out a secant x, so I'll just go ahead and do that now. This has 1 secant x, this has 3, so we can at least factor out 1. Okay, and so now we're at this point, and so from here, we have what the derivative of our function is. We can go ahead and evaluate it at x equals pi over 4, okay? So first things first, you may not necessarily know what secant x is when x is pi over 4, but you probably know what cosine of pi over 4 is. So we'll change all of our secant x terms into 1 over cosine x. So to help us be able to better identify what's going on there. So I'll also go ahead and write the 45, 45, 90 triangle. And of course we know 45 degrees is the same as pi over 4. And here's the relationships in between the sides. So this will help us quickly be able to identify what all this will be. So here I could rewrite secant as 1 over cosine. Go ahead and plug in pi over 4. Tan squared of pi over 4. And secant squared, which we know we'll put as 1 over cosine squared pi over 4. Okay? So here we know cosine of pi over 4, or cosine of 45 degrees, is going to be adjacent over hypotenuse. So we have 1 over 1 divided by square root of 2. Here, tangent of pi over 4 is just going to be opposite over adjacent. So that's just going to be 1. So we take 1 and square it. And of course, this is the same thing as it was over here, but it's just squared now. So 1 over 1 times 1 divided by square root of 2 squared now. Okay. And so, of course, the reciprocal of 1 over square root of 2 is just square root of 2. 1 squared is just 1. And of course, here, if we square 1 over square root of 2, this just gives us 1/2. And the reciprocal of 1/2 is 2. And if we put that all together, we end up getting 3 times square root of 2 as the answer. Okay. So again, to recap, started off with the function secant x. We took the first derivative, then we employed the product rule to do the second derivative. And then after that, we went ahead and plugged in x to let it be pi over 4, noting that secant x could be rewritten as 1 over cosine x. Okay. So now we have one other example, and then this will conclude this particular portion of the differentiation rules. Okay, so for our last problem here, we want to find the equation of the tangent line of this particular function at the point 0, 1. So we start off, we know that to find the equation of the tangent line, we need the slope of the tangent line. And of course, the slope of the tangent line is the same as the derivative of the function. So here, is just going to be y prime. And of course here we know that since we have e to the x times cosine x, we're going to be employing the product rule again. So derivative of the first function e to the x times cosine x plus derivative of the second function times the first. And so we keep going with this. We know that the derivative of e to the x is just e to the x. Write down cosine of x plus the derivative of cosine x is just minus sine x, as we see here, times e to the x. And so now, in looking at this, both terms have a e to the x, so we could factor that out. And what we're left was cosine x one term minus sine x second term. So now we know that this is the same as the slope of the tangent line. And now we want to evaluate this at the point 0, 1. So here, if we let x equal 0, we'll find out exactly what this is going to equal. okay? So here we know that anything raised to the 0 power is 1. We know that cosine of 0 is going to be 1, and sine of 0 is going to be 0. So all that just says that our slope here ends up being 1. So now if we look at what is going to be the equation of the tangent line, notice that this point here is a y-intercept. So if we were looking at this in terms of slope-intercept form with a slope of 1 and a y-intercept of 1, we know that our equation of the tangent line that goes to this point would be this particular equation here. And so with that, this concludes the trigonometric portion of the differentiation rules series.